All right. Hello, everybody. We'll get started here with our webinar on simulation and flow simulation express. Let's get started. My name is Ryan Borger. I'm an application engineer here at Design Point. I've been using SOLIDWORKS for over 15 years at this point, and the simulation products, the whole variety of them, for over 7 years now. So I can fairly speak from experience here in saying that these tools we're about to take a look at here today are extremely useful for the whole spectrum of users, whether you've never touched any kind of simulation product before, or if you're very experienced with a simulation product. These are fantastic tools to take a look at. So with that being said, let's get started here. So first thing I want to talk about is what is an Xpress product, because there are several other ones out there besides simulation. So an Xpress product is going to be a limited version of some other product that we have in our SOLIDWORKS tool belt. So for example, with simulation specifically, we have full versions of simulation that range from some fairly basic stuff to some extremely complex analysis that we have available to us. So for Simulation Express, for example here, we do have some limitations with them in that maybe we can only do, say, parts, smaller number of forces, things like that, which we'll talk about in a few minutes. But what's really great about these Express tools is it is available in every single license of SOLIDWORKS that you exist. So whether you're a user who has a SOLIDWORKS standard license or a user who has a SOLIDWORKS premium license, you have access to these tools we're about to take a look at here today without pulling an additional license. So that kind of leaves it to no excuse to not use them. So it's a pretty awesome thing to look at. So I want to start here this morning by taking a look at Simulation Express. So let's talk about that here. Where is it located? Well, when you open up SOLIDWORKS and you have a model in front of you, it is going to be located on our Evaluate tab. This does have a limitation in that we can only analyze parts. Multi-body parts do not count. It does have to be a single body part, but we can simplify models very easily with some of the different functions within, simulation here. We can simulate forces and or pressure loads on our model. So very basic forces, pushing on a face, pulling on a face in a specific direction, and the same thing with pressures as well. And the beauty of it is there is no FEA experience needed whatsoever. We're going to be taking a look at what's called the Analysis Wizard, and it walks you through step by step how to set up your simulation study, and it even helps us a little bit with some of the evaluation at the end. So with that, let's go ahead and jump into SOLIDWORKS now and take a look at SimExpress. All right, so we have a part open right here. And the first step before even beginning any analysis is to just imagine what you're trying to study on this part. What are we doing with it in the real world? What is its purpose and what are we trying to get out of it? I'm going to suggest for this piece that we're looking at, this bracket, that it's going to be mounted to a wall, probably via this face that I've highlighted in blue. Now we have to set up some credentials here. I'm going to say that I don't care how it's mounted to the wall. I don't care what the wall is going to be doing. I just know it's attached to a wall and it shouldn't move whatsoever. So that's an important detail we'll come back to in a minute. I also want to think about, well, what am I doing to this thing? Well, on this face that's going to be highlighted here in blue, I'm going to suggest that I'm going to push down on that face with some kind of a force. So let's take a look at that. How do we set this up? Well, once again, on our Evaluate tab, you can see I'm already there. I'm going to move all the way over to the right-hand side, and we're going to use this button here, Simulation Express Analysis Wizard. So I'm going to go ahead and click on that, and it loads up our Analysis Wizard on the right-hand side. This tool is going to walk us through everything that we need to set up our study. Now, right now, this part, I actually have run a SimExpress on it already at this point. So if I were to click on that options button there at the bottom, for example, I can go back and look at previous results, but I want to start fresh so we can see the start to finish process here. So I'm going to hit this next button to get started. And you can see at the top of our window here on the right-hand side, we have a list of 6 different things that we can go through. Now for today, we're only going to focus on the top 5. Optimization is something that we can spend hours talking on. It's a fantastic tool, really useful, but before we can get to there, we need to understand how to work the simulation first. So we'll come back to that at a later date. Now you notice here, highlighted in bold, we have this first list item here called fixtures. That's going to be the first thing we're going to set up. There are 3 major things that we need to be aware of when setting up any simulation study, and that's going to be fixtures, loads, and materials. They are the absolute most important things that we need to work with within our model. So to get started here, we're on the fixtures tab, and it talks you through a little bit of information on how these fixtures work. You can see there's some links right here that if I hover over them, it shows what they do. So if you're not really experienced with what the fixtures are capable of, fantastic tools are built in right there to help walk you through this. So I'm gonna hit the button here for add a fixture, and it's gonna open up on the left-hand side my property manager for fixtures. So think of a fixture as a command for your dog, a sit and stay, right? Don't move anywhere whatsoever. And we're going to apply that don't move condition to, say, a face, an edge, or a point. And if you recall back when I was talking about how we're going to set this thing up, I said this back face is going to be attached to a wall somewhere and I don't want it to move. Well, that's what we're going to do right here. I'm going to click on that face, and that face now gets propagated over here in our property manager, indicating that is not going to move anywhere for us whatsoever. And they do even provide a little animation showing how a fixture behaves with this green face being the piece that we actually ended up fixing. All right, so I'm happy with that. Nothing more is needed there. I'm going to click OK. And now once that's applied, 2 things happened. First thing I want to focus on is going back over here to the analysis wizard. You notice we get a green check mark next to our fixtures line item, which means we have something there. We're in good shape. Excellent. Now moving back over to the left-hand side, once we do that, we now have a simulation design tree. And as we start adding things to this study, they're going to propagate over here for us to take a look at and modify if we need to. Perfect. All right, going back over to our analysis wizard, it's giving us a couple options here at the bottom. It's saying we can either add another fixture, we can edit an existing fixture, or we can move on to the next step. So you can see it's walking us through the ability to do anything we want really at this point. So I don't need to add any more fixtures. I'm happy with the one that we have, so we can move on to loads. So here we go. Moving on to loads, we have 2 choices. We can either add a force or we can add a pressure. So in this case, since I said we're going to be pushing down on this circular face here in the middle of the bracket, we're going to consider that to be a force. But do know that you can mix these things together. I can add a force in one direction and maybe there's a pressure in there as well, or multiple forces. We're not limited from that front. So I'm going to click add a force. And once again, just like what we saw with the fixtures, it opens up on the left-hand side, our property manager, the ability to choose something that this force is applied to. However, we are limited here in Xpress to only applying forces to faces. So just keep that one in mind. And I'm just going to come over here to the model and click on the face that I want the force to be applied to. All right, a couple options here. We can have this force applied in a specific direction, either normal to the face, up or down. So I'm actually going to jump down to the bottom. There's a little reverse direction button, so you can see I can switch that around if I need to. So it could be pushing or pulling. We can also select a specific direction. So if I had, maybe I wanted a shear direction, I could select another face here and have the force applied in a shear direction if I want. But normal to is perfectly fine for this one. Forcing it down. And all we have to do in this box is apply some kind of force. So let's do, I don't know, 500 pounds, something like that. And once you're happy, we click OK. And there we have it. Again, in our design tree, we can see now we have something new here. We have our force that we applied. It even specifies what it is. So it's easy to look at and either make a change or confirm everything is set up the way that you want. Excellent. All right, so let's go back over to the analysis wizard. So just like what we saw with the fixtures, we now have a green check mark next to our load. So we're on our way. We have 2 of the 3 important items already set. So coming down to the bottom, again, more options. Do we want to add another force? Do we want to add a pressure to this? Or do we want to edit one of the existing things that we've created or move on to the next step? So for our conditions for this model, we're set. There's nothing more needed here. So we can go ahead and move on to the next step. And that next step is materials. Now do note, if you model your parts with a material already applied to it in the model design tree up here, it will propagate over to the simulation study. But you notice with mine, I didn't specify a material in my design tree, but that's okay. We don't have to go back and change it. I have the option to add a material right here within the simulation study. So we're going to hit choose material, and it's going to open up our materials library for us. Now, we have lots of options within our SOLIDWORKS materials library. We can download materials from different websites. We can make our own custom materials, or we can use the many options that are within SOLIDWORKS just by an installation itself. The only thing I would suggest here is just keep in mind, when we're picking a material, if you look at the properties over here, you notice some of them are in different colors, red, black, and blue. The red are the most important ones for you for Simulation Xpress. When we go to select a material, we need to make sure any option that's in red has a number value next to it. Let me show you an example of one that does not have it. If I scroll down here and take a look at, say, a beechwood, you'll notice there are no properties for elastic modulus, Poisson's ratio. It does have mass density, but because these two are missing, if I go to try to run a simulation study with this as a material applied to it, it's not going to be happy. It's going to ask us to provide that information. So just be aware of that. Make sure you're selecting a material that does have all of its properties. For this one, let's pick, say, a plain carbon steel. We'll keep it simple. And just to double check, everything in red does have a number next to it. So we're in good shape. So we can go ahead and hit apply, and we'll close out of the material library. And we can take a look over here again under analysis wizard. We get a green check mark, and it gives us the information that's going to be needed for this specific study. So it doesn't always use everything in red. It just depends on how the model was set up. All right. So again, more options. We can either change the material to something different or move on to the next step, which is going to be to run the study. So I'm going to hit next to go ahead and run this, and we'll hit run simulation. And this is pretty quick. It's just going to go ahead and create a mesh and then run the study. And now we get this animation that shows up. Now, this part tends to confuse people sometimes a little bit because we get distracted by the interesting animations that are happening in the model. So let's ignore that for a second. Let's take a look over here at the analysis wizard. It asks us a question here: does the part deform as you expect? In this case, what we want to do is take a look at the animation and say, all right, well, I fixed this back face over here, so that shouldn't move, so that's great. That's looking in good shape here. And I have force pushing down, and we can see the deflection is going down. So I think it's fair to say, yes, it's deforming as I would expect it to. It might be exaggerated, but it's deforming in the direction I would expect. For example, an instance where it might not is if I had this force pushing down as I do now, but yet the animation was going upwards, that might be an indication of a fixture not being set up correctly, or a force not even being set up correctly, right? We might check a box somewhere to reverse the direction where we didn't intend on it just by accident. So this gives us an opportunity to make sure everything is good to go before we start viewing results. So in this case, I can answer the question and say, yes, we are in good shape. I can go ahead and continue, but do know you can say, nope, that's not right. And it will return me back to the setup so I can take a look at the loads and fixtures and make adjustments as needed. So we're gonna hit yes and continue. And now what it's doing here is opening up one of the first results viewing options, or what's known as post-processing, which is a factor of safety chart, one of the most popular things besides a stress plot inside of any of our simulation studies. So what this is doing right now is it's going to show me on the von Mises stress plot a factor of safety of whatever number I choose. So you can see right here, I'm saying show a factor of safety that is below whatever number you want in case 1. Now this is a live update, so anything that is above the factor of safety of 1 will be indicated by blue, and anything below these conditions over here will be indicated in red. And if I rotate the model and look around, we're nowhere near any issues whatsoever with factor of safety, which will also prove that again when we look at the other plots. I'm just gonna make this extreme. Let's say if I bring this up to, say, a factor of safety of 15, now you can see some colors are popping up here for us. So we have some red showing up down at these fillets. So that just means the factor of safety is below 15 in those areas there. All right, so that's only one plot. There's plenty more to take a look at. We can always come back and edit this as well. So I'm going to hit done viewing for the moment, and we're going to leave our analysis wizard alone over here. There's some other things that it can do, which we'll talk about at the end. What I want to do is go back over to the left-hand side and look at our simulation design tree. We have now a results folder with 4 different plots. 3 of them are going to be what I would say useful for post-processing. One of them was already used and we don't really need it at the moment here. So let's take a look at them. First one here at the top is our stress plot, and this is the von Mises stress. If I want to view this, I double click, and now we can take a look at that stress. Now there's a lot going on right here, so let's break this down into some manageable chunks, because this tends to be a very interesting area where sometimes we immediately look for the bright colors and say, uh-oh, something's going wrong. So let's break it down first before we do that. First thing I want us to look at is this legend that pops up over here on the right-hand side of the screen. This is showing our stress values for inside the plot and associating it to a color. At the very, very bottom, we see this arrow here indicating the yield strength, and this is the yield strength value that was depicted in the material properties. So this isn't calculated, this is just a factual property that we can use here. Now, what I want you to be aware of is taking a look at this color chart that shows up here. If you see this arrow popping up anywhere next to a color, that indicates that in this model somewhere, we hit yield, meaning we hit permanent deformation. Now, since I don't see this arrow anywhere here, I haven't hit permanent deformation, which means if I unload that 500-pound force, this thing is going right back to normal and life is good. In fact, we can even take a look and see the highest stress value, even though it's indicated by red, which most people associate red as bad, the highest stress value is nowhere near the yield strength. So we're in pretty good shape right here. Once we understand what that plot is showing us, now we can come over and take a look at the model and look around and say, oh yeah, yep, there's the red spots. Yes, it's high stress, but it's nowhere near the yield in this case. But that's still valuable information, right? We can go back and we can modify the model if we want. Maybe we want to try to spread that stress distribution out a little bit more. So maybe we make a larger fillet or some other design change, right? It doesn't matter, it all talks back to the model. So if I go back and make a change over here in my design tree, that change will come into our simulation study, and all we have to do is rerun it, and we can take a look at the new results. So it still maintains that dynamic ability that we've always been used to within SOLIDWORKS in general. All right, so that's our stress plot. The other thing I want to mention too before moving on to the next one is if I rotate around, you can see this thing is deflecting a lot. Now, relative to this model, 500 pounds really is not a lot for how thick this material is right here. So in actuality, this thing isn't going to deform as much as it physically looks like right here. That's part of what's happening within the Simulation Express module is it exaggerates the deformation from anywhere from 50 times to 500 times the actual amount, so that we can actually see that, yes, there is some deformation. And that will become very evident here when I look at the displacement plot. Let me double click this one. And now we can see how much this thing is actually moving. So again, it's deformed, it's exaggerated, but if we look at this, the largest amount of deformation, which is at the end, as we would expect, in red here is 5.611 e to the -4 inches. So that is really, really tiny when this is, I believe this is a 4 or 5 inch tall bracket. So it's a very small deformation, but again, the numbers are associated with colors to help us see that and understand that in a better fashion. And then our next one here, our deformation plot, we've actually used this one already. If I double click on this, this was the plot that was used to create the animation that we saw at the very, very beginning when we were trying to verify if this is moving in the correct direction or not. In fact, I can prove that if I go ahead and right click on the plot, there's an option to hit animate, and we're going to see that same movement that we saw before when it was saying, hey, is this doing what you would expect it to do? So that's all good to go right there. And then the last plot we've already looked at is our factor of safety. So right now, this is showing me the factor of safety for, I believe it was 15 that I put in, and we can see it's showing up right here is the factor of safety of 15. If I want to change that, if I go back to my analysis wizard, I can hit the back button, and I can go ahead and change that factor of safety plot to something else. Maybe we care about Is it hitting a factor of safety of 5? And now you can see the plot updates, and yes, it looks like we're in good shape on this one. Perfect. All right, so let's recap a little bit here on what we just covered with Simulation Xpress. So again, it is with parts only. If I tried to run an analysis on, say, an assembly, when I go to click on Simulation Xpress, it's going to tell me, hey, we need to go back and work on just a part only. But we have the technology to do that. So it is just on parts only. We are working with forces and pressures only in this case. And again, it's located on our Evaluate tab. And all this information is stored within the part file. So if I hit save and close out of this, I can always come back and take a look at this information again if I ever need to see it. Perfect. All right, so let me switch back over here and let's take a look at our next tool. We're going to look at Flow Xpress. So this is the Xpress version of Flow Simulation, which is a CFD fluid analysis tool. And we have a lot of different things we can do in the full tool, but there's still a lot of great things that we can do within the limited Xpress tool right here to get started. So again, just like our Simulation Xpress is located on our Evaluate tab, this time, in addition to being limited to only parts, just like within our Simulation Xpress, we are also limited to internal flow only. So let me elaborate that on that for a quick second here. There's two different flow versions we can work with inside of flow simulation. One is internal flow and one is external flow. Think of internal flow as a fluid moving through a pipe. Flow in, flow out, right? External flow, think of it as, say, an airplane wing. We have something going around something, so around an airfoil, something of that nature. So we are working with internal flow only on parts. And as far as our results are concerned, we are going to get flow trajectories showing velocity of whatever fluid we choose, and that fluid can either be air or water. That's another version here. Just note that in the full version of flow simulation, there are hundreds and hundreds of different fluids that we can utilize and create our own as needed. And just like the other Xpress tools we've taken a look at here, no experience with flow simulation is needed. It walks us through what needs to happen. And this time, instead of being through the simulation analysis wizard, it's actually within the tool itself. So it's all integrated within one. All right, let's take a look at that. So let me jump back over to SolidWorks here. Let me just close out of our previous one. We don't need that anymore. And this is going to be our flow model that we're going to look at. It's just a really simple cyclone. So I want you to take a look before I open up the tool. Over here in our design tree, this is actually a multi-body part. And that kind of contradicts what I just said a minute ago, right? This is for parts only, single parts only. Flow simulation needs an internal study to be completely encapsulated, completely closed. So we create what are called lids to close flow openings, either where something's coming in or where something's coming out. And we just utilize multi-body techniques. So if we take a look here at the top, I have this little cap that's highlighted in blue. That's just plugging off where, say, the air is going to be sucked out of the cyclone. And then I have another one that's capping basically the inlet of the cyclone right here as well. So that's the only thing that we have to be aware of. We just have to cap those ends off, no big deal. Now, just to make this a little bit easier to see and work through the study and look at the results, I'm just going to do a quick little section cut and just rotate it around a little bit so we can see what's happening on the inside of this cyclone. And let's get started. So just like we did before on the Evaluate tab, we have this Flow Simulation Analysis Wizard. I'm going to click on that. And this time it's going to open up on the left-hand side, walks us through everything, just like we saw before. It gives us a little introduction message of what this is doing. It does mention what I just talked about here to make sure that any openings are completely closed with lids. It will do a detection when I go to click this next button right here. If there's something that's open to the environment that's not closed off with a lid, it's going to say, hey, something is missing here. Please go back and close it off. So when I go to click next, we're going to see if we did it correct here. So we'll click next. And we're in good shape. It says the geometry is okay. I can view the fluid volume area of what's happening if I want, but in this case, we already know what's happening here. So I can go ahead and click next again. And now we choose What are we running through this? Again, here is one of the limitations of Flow Xpress is that we do have these two fluids here, either water or air. But for the majority of the time, that's mostly what we're working with. So we're going to pump air through this. So I have air selected. I'm going to click next. And now we can go ahead and start setting up the inlets and the outlets. So we are limited to one inlet and one outlet. And a couple different options for these inlets and outlets here. We have pressure openings, volumetric flow rates, or mass flow rates. It's totally up to you which one you want to utilize. I'm going to use a pressure opening for the inlet, and the inlet is over here. I'm going to suggest that we don't have this connected to any other system. It's just wide open at this point. We want to know what sort of flow rate we're going to get if this thing was just completely open. But we could have a piping system on this thing if we wanted as well. Now, when we go to select these, it is important that whatever we select is on the inside of the closed-in fluid area. And what I mean by that is if we take a look at this lid, you have two faces to apply this pressure opening to in this case here, either the outside face or this inside face. The outside face is not part of any of the internal fluid regions. So this is an internal study, so we're going to stick with the inside face. So I'm going to select that face right here. And you can see we have the option to choose what the environmental pressure is and what the temperature is, because that might change things for us as well. So I'm going to keep this at the standard 1 atmospheric pressure level here, and roughly room temperature 68 degrees there is looking pretty good. So that's fine for this version. We'll go ahead and click next to move on to our outlet. So again, for the outlet, we can choose either a pressure opening or some kind of volumetric flow rate. That will be determined by whatever you select for the inlet. So since I chose a pressure opening for the inlet, I can choose a volumetric flow rate for the outlet here. So just like we did before, I'm going to select the inside of our lid, and we want to pay attention to those arrows. You can see the red arrows for our flow rate, they're going up and out. And that's what I want in this case. I want to make sure they're going in the correct direction. If not, we come down here to what that flow rate is and we pop a negative sign in front of that number, and that will move it from one side to the other. In this case, 30,000 cubic inches per second is good enough. That's it's up there pretty high in the CFM range, pretty standard for a cyclone. So it looks pretty good. I'll go ahead and hit next. And that's all we have to do for the setup. It's pretty straightforward. It's an inlet, it's an outlet. As long as everything's enclosed, we can go ahead and solve the study. So I'm going to hit this play button to solve. And what it's going to do in the background here is it's going to create cubic mesh areas, or volumes I should actually say, and it's going to analyze the inlet and the outlet and the rest of the geometry that's closed in to create flow trajectories displaying velocity of, in this case, how fast the air is moving through in different parts of our model. So once it's done solving, it's going to go ahead and show us the results. And just to, again, to recap, I do have this in a section view so that I can see what's going on the inside a little better. We could also change the transparency of the model as well to get some better views. And there we go. We have a result. So let's take a look at what's happening here. First, let's look at the graphics area. Just like what we did with our Simulation Xpress, let's look at this chart. We can see the chart has a bunch of colors associated with numbers, and these are related to velocity, in this case, inches per second right here. So we can take a look at those different colors and see what's happening. So the inlet's got some pretty decent sized velocity going on right here, indicated by those yellow spheres. Our highest velocity looks like it's getting closer to this outlet tube here. Got some red ones right down here at the bottom, so that's pretty fast. And then pretty standard for a cyclone of this style right here, we have very little velocity, if any, down here at the bottom. So looking pretty good. Now, looking at our property manager on the left-hand side, we can go ahead and play this animation if I hit the little play button, so we can actually see these spheres, in this case, moving through. And they're trying to relate, this isn't a 1-for-1 velocity right here. The colors, the numbers are a 1-for-1 velocity, but you notice these yellow spheres, let me go back to this right here. The yellow spheres, they're moving on that inlet at a decent pace, and then the blue ones down at the bottom, they're going the slowest because they don't have as much velocity. So it is kind of a relation there for us to see. So that's kind of nice to take a look at. I'm going to stop that animation so we can see what else is happening here. The number of spheres that we're taking a look at right here, I can change that. They're called trajectories. So if I take this little drag bar and say move it backwards all the way to the end, we're showing only one. So I'm basically seeing almost as if it's one particle of air in this case. It's not a full particle study, but it's just showing me how that one air particle could be moving around, and I can move that up quite a bit higher right here. So you can see I drag that up pretty far. It will get a little messy sometimes to look at, but sometimes that's great information to have to see what's actually happening here. And we can choose, right now I have the little spheres showing. We can also switch this to pipes to make little like spaghetti noodles right there. If you animate this one, it looks a little bit different. It basically starts at 1 and it completes one string all the way through from the start to the end. So that's pretty interesting to see. All right. And the last thing that you can do in here is we can generate reports from this. It will basically take screenshots for us right here. We can take screenshots here as well. So I can snap an image of what we're looking at on the screen right here. So you can see it shows up. I can create multiple. I can rotate around and look at things in specific areas and snap additional images. And these can all be put into our reports if we need, or we can copy those images and use them however we feel fit. Excellent. All right, and if I click OK, it basically turns off the flow analysis for me. I can go back to my model. If I need to make changes to anything, maybe we look at those results and we don't like the way some things are flowing around different areas, different geometry, we can make changes. And then I can go back to my flow analysis and it remembers where we left off. So I can go ahead and look at my previous results right here, or I can hit the back button and make some changes if I need to do that. But if the geometry changes, it will recognize that and it will have me rerun the study so that we can see the newest, latest results. All right, excellent stuff right there. So again, recapping, let me switch back over here and let's take a look here. So again, the Flow Xpress analysis located on our Evaluate tab, internal studies only on parts, flow in, flow out, and our results show us velocity of that fluid in a trajectory fashion. Excellent. All right, guys. Well, that's all I have for us with our Simulation Xpress products here. So if you have any questions or comments, please feel free to give us a call. We can be reached at that phone number on the screen there, 1-844-721-7211. We have an excellent staff who's very knowledgeable on any of these products. If you have any questions on the full versions of any of these products that you saw here today, whether it's flow simulation or I'm just going to call it regular simulation, again, feel free to give us a call and we'd be happy to talk about it, give demonstrations, and go from there. All right, I hope everybody has a great day.